G of x is the parabola. Axis of symmetry of a parabola is always a vertical line, a dotted line that goes straight through the turning point. So all we need for the axis of symmetry of a parabola is the x value of the turning point. So in this case here, the x value of this turning point would be positive 2. Alright, so the axis of symmetry of this parabola has the equation x equals 2. Okay, for question 7, they want the equations of the asymptotes of f of x, and this is a hyperbola. Okay, now you all know that what an asymptote is. An asymptote is either a vertical or a horizontal line that the graph gets closer to but never touches. Okay, so the equations of the asymptotes of this hyperbola will be x equals something for the vertical asymptote and y equals something for the horizontal asymptote. Because this hyperbola has been shifted up 4 units because of that 4, we know that the horizontal asymptote is up at y equals 4. And because this hyperbola has been shifted to the right 4 units, we know the vertical asymptote has the equation x equals 4. If you're finding the g of x minus 3, because 3 has been subtracted from that x, it means that that whole parabola just shifted 3 units right. Okay, now the initial turning point was 2 with 9. Get it from the standard form. So if that thing is shifted 3 units to the right, its new turning point will move from 2, 9 to 5, 9. So there it is. Number 9 is about the f of x, which is the hyperbola. They're asking if it's reflected over the x-axis, the domain would not change. Is that true or false? Here is the f of x as they give it to us. I've very roughly drawn it here. You can see there I drew it. You see the plus 4 and the 2 asymptotes have shifted, 4 to the right and 4 up. And because it was positive, it's in the first and the third quadrant. So basically this is how the f of x looks. Okay, so now if I reflected that about this x-axis, it looks like that. This part here at the top just went underneath here, like that, you see, like this is, and this here just flipped as if this was a mirror. So this bit's underneath, you see, and this bit's at the top. So basically you can see that if this reflects over the x-axis, the domain is not going to change at all, because it's still going to the left forever, it's still going to the right forever, and the only x value that the hyperbola doesn't touch is this x equals 4. You see, it's the same for both. So the answer to that question was true. If f of x is reflected over the x-axis again, now they're asking the equations of the axis of symmetry will remain unchanged. Here's the original f of x. You can see that its axis of symmetry is here, and the other one would be here somewhere. Agreed? Make sure you know the difference between an asymptote and an axis of symmetry. Okay, anyway, just look at this 45-degree line here. That's one of the axes of symmetry. When this thing got reflected, do you see this the same axis of symmetry from here? Do you see how it's not an axis of symmetry anymore? So that proves that the answer to number 10 is false.